So now we can move on to solving linear equation in one unknown. Usually, when we solve, we would do the same operation on both sides. Let's take this as a simple example. For x plus 10 equals to 22, we would like to make x as the subject. So we would like to cancel out the effects of plus 10. And then we will move forward to minus 10 on both sides, which would give x equals to 12. And for this example, y minus 9 equals to 27. Again, we would like to make y as the subject. So we will plus 9 on both sides in order to cancel out the minus 9 on the left hand side. And this would give y equals to 36. So instead of just saying that we do the same operations on both sides, we can also say we transpose a term when we solve an algebraic equation. Let's take this as an example again. If x minus a equals to b, we can say we transpose this term to plus a on the opposite side. So it would equal to x equals to b plus a. And if it is x plus a equals to b, again we can say we transpose the plus a term to the opposite side. It would then equal to x equals to b minus a. So it's very simple. Let's look at these two calculations. X minus 10 equals to 14. The junior way is we need to write an extra step of x minus 10 plus 10 on the left hand side equals to 14 plus 10. But now we can say we transpose this minus 10 to the right hand side and directly write x equals to 14 plus 10. So the final answer should be 24. And here another example, x plus 13 equals to 26. We can omit the step of writing both minus 13 on the left hand and right hand sides, but we can directly transpose the term by writing x equals to 26 minus 13. So finally it's 13. The answer is 13. And again, for transposing terms, it's not just limited to addition and subtraction. It's also applicable to division and multiplication. Let's say if we have a statement like this, a times x equals to b, we can directly transpose the times a into divided by a on the right hand side. Or if we have a statement x divided by a equals to b, again we can transpose this divided by a into multiply by a on the right hand side. Again, it's very simple. So in application, when we have 3 times x equals to 9, we directly transpose the term on the right hand side. It becomes divided by 3, and final answer is 3. If we have x divided by 4, we transpose the divided by 4 to times 4 on the right hand side, and then it would equal to minus 848. So here are some other a bit harder examples, including 2 terms on the numerator. If l plus 1 divided by 3, we can transpose the term times 3 to the right hand side. It would give 24 on the right hand side. And finally, we transpose this plus 1 into minus 1 on the right hand side. The final answer will be l equals to 23. And again, this example is a little bit different from the example we see previously. And here, the term of plus 1 is separated from w divided by 4. So we need to deal with this plus 1 first. We will transpose the plus 1 to minus 1 on the right hand side. But please bear in mind that we cannot directly multiply by 4 on both sides because these two items do not have the same denominator. So we minus 1 on the right hand side, or transpose plus 1 to minus 1 on the right hand side, it gives 12. And then now we can multiply 4 on both sides. Or we say transposing the 4 to multiply 4 on the right hand side, and it gives 48. Let's look at other cases. Usually in algebra, we always need to deal with algebra and numbers in brackets. So in this case 1, this is basically 2 times a whole bracket of x plus 3. So it means we need to multiply both members inside the bracket by 2. It would give 2x plus 2 times 3, it means 2x plus 6. Again, case 2, 2 times x minus 3. For each member inside the bracket, we need to multiply by 2. It would give 2x minus 6. So you can see that if the coefficient before the bracket is a positive number, it would be a bit easier to deal with. But if it is a negative number, just like in case 3, we also need to multiply both members inside the bracket, and we need to deal with the negative side very carefully, because minus 2 times x gives minus 2x, and minus 2 times plus 3 also gives minus 6. And for case 4, we can see sometimes the sign will even change. If the sign inside the bracket is a negative sign, minus 2 times x minus 3, it would give minus 2x and plus 6. Because please bear in mind that minus 2 times minus 3 gives positive 6. Or minus a number times minus another number would always, the both negative sign cancels out, and then it would give a positive sign. So let's take a look how to deal with equations with brackets. For the first example, 4 times bracket p plus 9 equals to minus 20. We can see the left-hand side as a whole unit, and we can transpose the term 4 to divided by 4 on the right-hand side, and it would give p plus 9 equals to minus 5. Again, when we transpose plus 9 to the right-hand side, becomes minus 9. We can have the answer of p equals to minus 14. And for the example on the right-hand side, we can see there are 2 terms on left-hand side and right-hand side having k. Our first aim is to group the like terms together first, so that finally we can make k as the subject and solve the equation. So the first step can be we expand this bracket by multiplying each member by 5. So it's 5k minus 10 minus 6 on the right hand side, and it gives us to look at what's the difference between these two examples. For the first example, we don't need to separately multiply 4 into the members, because we can already separate or isolate p by just transposing the 4 into the right hand side. But for the example on the right hand side, here we have no other ways to isolate k unless we multiply 5 into the bracket and then separate these two items. So after this step, we can think about how to group the items with k together. So first we would transpose minus 2k to the right hand side. It would give 7k altogether. And all the numbers we can group together. It would give 12 plus 10 plus 6. So finally we will have 7k equals to 28. And then when k is the subject, we transpose 7 to the right hand side by divided by 7. It would give 4. Another example with brackets. Now we can see that 6 times z plus 10 minus 3 on the left hand side. But again, because 6 is not a common factor for all the items on the left-hand side, we need to first deal with the minus 3 by transposing into plus 3 on the right-hand side first. And either we can transpose 6 by dividing on the right-hand side by 6, or we can multiply each item within the bracket by 6. And finally, after simplifying, it gives z equals to minus 6. And the example here, we notice that there are more than one terms with q. So first of all, we would aim at grouping all the like terms together. So we need to expand this bracket. Multiplying by 2, it gives 14q minus 8. Here, again, minus 4 multiply q, and minus 4 times 5 is minus 20. So we can put the like terms together, 14q plus 4q by transposing the minus 4q to the left-hand side, and then we group all the numbers together on the right-hand side. Finally, it would give 18q. 18q equals to minus 6. And the q becomes the subject. We can transpose 18 to the right-hand side by dividing 3. It would give minus 1 over 3 as the final answer. And here, similarly, we can see we first try to put all like terms together. So after expanding this bracket, minus 6 times 2u is minus 12u. Minus 6 times minus 3 is plus 18. And obviously, we would put all the items with u together. So we would have 3u plus 12u. And then left-hand side would become 30 finally. And then again, we transpose the 15 by dividing 15 on the left-hand side. And then u would equal to 2. And here it looks like a bit complicated, but actually the principle is the same. We first expand the smallest bracket. It would give minus 2m plus 14 because minus 2 times minus 7 gives positive 14. And again, we would try to put like terms with m together so that m can be finally the subject. So we will simplify this to become 19 minus 2m, and then either we can transpose 4 by dividing 4 on the right hand side, but we can see that it's not so convenient because 3 divided by 4 is not an integer, nor 10 divided by 4. So we would choose to multiply 4 into each member of the bracket, and then finally we can put items with m together is xm plus 3m, which gives 11m. And putting all the numbers together, 76 minus 10, 66. Finally, transposing 11 by dividing 11 on the left-hand side, it would give m equals to 6. And for equations with fractions, basically it looks like more complicated, but sometimes it could have less steps than equations without fractions. And the principles basically are the same. First of all, we can try to, there are more than one methods. So for the same equation like this, a divided by 3 equals to 1 minus a divided by 4, we can first find the LCM of 3 and 4, which are the denominators of two different fractions. Obviously, it's 12. So the principle is multiply the whole equation on both sides by 12. And then it would give 4a on the left-hand side. 12 minus, we simplify 12 times a over 4, which would give minus 3a. Minus 3a on the right-hand side. So finally, the answer should be a equals to 12 divided by 7, or 12 over 7. But there are also another method which actually is similar to finish the same equation, to solve the same equation. For the first part, instead of finding the LCM and multiply the whole equation by 12, we can find a common denominator on the right-hand side first, because here is an integer minus a fraction. And so we can find a common denominator first by making the numerator as 4 minus 8. And the denominator is 4 here. And in this way, we would then naturally multiply both sides by 12. But this time, we will not need to multiply 12 with another integer, which is 1 here. But we will simply simplify with the denominator of the whole unit. So finally, on the right-hand side is 3 multiplied 4 minus 8. Left-hand side is like this. And finally, after simplifying the whole, we would have a equals to 12 over 7, which is the same as another method. So it depends which method is more handy for individuals, more convenient for individual. If you are more used to this method, you can just simply multiply both sides by an LCM. Or if you are more used to first finding an common denominator for an integer and a fraction, you may also do in similar way. So another example is also equations with fractions. For e over 3 minus e over 5 equals to 10, first, because we know that 3 and 5 would have an LCM of 15. So we will multiply both sides by 15, which is the simplest or most straightforward way. And after simplifying, here it would give 5e, and 15 times minus e over 5 would give minus 3e equals to 150. And finally, after simplifying, it would give e equals to 75. But as we said before, we can also find a common denominator of two fractions or one integer, one fraction. So here obviously we can find a common denominator of 15. So the upper part you also need to expand accordingly. Because 3 times 5 equals 15, so the left side e would be 5e, the right side e would be 3e, because 5 times 3 equals to 15. And after simplifying, the upper part would be 2e, or we can simply just cross out the 15 first, and then it would give the numerator. And finally, you give the same answer as well by simplifying everything as in the method 1. Again, another example, we can see how to deal with equations with fractions. First of all, here we can see that we could just simply multiply the LCM on both sides, which is 6. And then it gives this answer finally. Or we can use another method by grouping the like terms together first. And here again, we can see that still the LCM is 6. But similarly, when we multiply both sides, we can simplify the like terms with v or simplify the number. So finally, by transposing minus 5 to the right-hand side by dividing minus 5, it gives v equals to minus 18. So basically, these two methods are quite similar. We multiply the LCM either directly or grouping the like terms together first. And similarly, still about equations of fractions with fractions, and here is a little bit more complicated that we have fractions which is not just including one item. The fraction in the numerator part, we have two items. So first, in order to group the like terms together, we need to either multiply both sides by the LCM, and then it would separately gives 2 times 3y and 2 times 5. And here is 6 times y over 6, that means just simply 1y, and 6 times minus 5. After simplifying, we can see that we can group the 6y and y together first, and it would give 5y on the left hand side, and then the final answer will be y equals to minus 8. And you can see here, basically, as we said before, either you directly multiply both sides by an LCM, or you can find a common denominator first on both sides. So here, the denominator is 3, but y over 6 minus 5 would give a common denominator of 6, and the numerator would become y minus 30, because 5 times 6 equals to 30. If you need 6 as the denominator. And then simply, we just multiply both sides by lowest common multiple is 6. And then finally, after simplifying, it would give y equals to minus x as well. Now it comes to setting equations to solve word problems. For example, the sum of two consecutive odd numbers is 84. Find the larger integer. Then we would either set x be the smaller odd integer, or we can set it as the larger odd integer. And if we set x as the smaller one, we would use x plus 2 be the larger one. Because consecutive odd integers means there's a difference of 2 between two numbers. So it's x plus 2 equals to 84. Finally, it gives 2x equals to 82, because we transpose the 2 to the right hand side by minus 2, and then x equals to 41 by transposing 2 to the right hand side by dividing 2. So of course, the larger integer would become 41 plus 2. It would give 43. Another example, the age of Joanne's mother now is 4 times the age of Joanne, and 5 years later, their sum of ages will be 50. Find the age of Joanne now. So the hardest part is always how to set up the equation to solve the word problem. For here, we can separate into two columns, one for the current age, and another column is for the age or the sum of age after 5 years. So for the current age, we can set Joanne's age is A, or whatever variable you want. Her mother's age is 4 times, so it's 4A. And 5 years later, everybody is 5 years older. So it's A plus 5 and 4A plus 5. And then we can apply the information from the question, the sum is 50. So we can write 4A plus 5 plus A plus 5 equals to 50. And then after simplifying, we would get the answer of A equals to 8. That means Joanne's age now is 8 years old. And if it is 5 years later, it would be 8 plus 5 equals to 13. Here it comes another example. Isabel Mandy has 4 times as many candies as Julie. If Julie gives 5 candies to Mandy, then Mandy will have 5 times as many candies as Julie. So basically, we can first set the number of candies that Julie has to be a variable, such as x. And then Mandy would have 4 times. That means she would have 4x. And this is the number of candies originally they have. Then afterwards, Julie gives 5 candies to Mandy. That means Julie would have 5 less candies, and Mandy would have 5 more. So we can write down these two algebraic expressions. And then the question asks, find the original number of candies that Julie has. That means we just need to solve x. So, because here it says Mandy will have 5 times as many candies as Julie after Julie gave her 5 candies. So we can say actually 4x plus 5, which is the number of candy Mandy has, would be 5 times the number of candy Julie has. So 4x plus 5 equals to 5 times bracket x minus 5. And we would get to this equation. And then, of course, after expanding n, we group the like terms together is 5x minus 4x, and then the numbers groups together. Finally, we will solve that x equals to 30. That means originally the number of candies Julie has is 30.